The Sun is a G-type main sequence star that makes up about 99.86% of the mass of the Solar System. It consists mainly of the elements hydrogen and helium. The distance from the Earth is 149,600,000 kilometers, and it takes light 8 minutes and 9 seconds to reach Earth. The core of the Sun extends from the center to about 20 to 25% of the solar radius. It has a density of up to 150 G/cm3, about 150 times the density of water, and a temperature of close to 15.7 million Kelvin. By contrast, the Sun's surface temperature is about 5,800 K. The proton-proton chain occurs around 9.2 by 1037 times each second in the core, converting about 3.7 by 1038 protons into alpha particles, helium nuclei, every second, out of a total of 8.9 times 1056 free protons in the Sun, or about 6.2 by 1011 kg/s. The radiative zone is the thickest layer of the Sun, at 0.45 solar radii. From the core out to about 0.7 solar radii, thermal radiation is the primary means of energy transfer. The temperature drops from approximately 7 million to 2 million kelvins with increasing distance from the core. The visible surface of the Sun, the photosphere, is the layer below which the Sun becomes opaque to visible light. Photons produced in this layer escape the Sun through the transparent solar atmosphere above it and become solar radiation, sunlight. The chromosphere and overlying corona are separated by a thin transition region, about 200 kilometers, where the temperature rises rapidly from around 20,000 K in the upper chromosphere to coronal temperatures closer to 1 million K. The corona is the next layer of the Sun. The low corona, near the surface of the Sun, has a particle density around 1015 m-3 to 1016 m-3. During a total solar eclipse, the solar corona can be seen with the naked eye. The heliosphere is defined as the region of space where the solar wind dominates over the interstellar medium. The Sun emits light across the visible spectrum. Its color is white. Sunspots are visible as dark patches on the Sun's photosphere and correspond to concentrations of magnetic field where convective transport of heat is inhibited from the solar interior to the surface. As a result, sunspots are slightly cooler than the surrounding photosphere, so they appear dark. The Sun's magnetic field leads to many effects that are collectively called solar activity. Both coronal mass ejections and high-speed streams of solar wind carry plasma and the interplanetary magnetic field outward into the solar system. The effects of solar activity on Earth include auroras at moderate to high latitudes and the disruption of radio communications and electric power. The Sun today is roughly halfway through the main sequence portion of its life. It has not changed dramatically in over 4 billion years and will remain fairly stable for about 5 billion more. However, after hydrogen fusion in its core has stopped, the Sun will undergo dramatic changes, both internally and externally. The Sun will spend a total of approximately 10 to 11 billion years as a main sequence star before the red giant phase of the Sun. At the 8 billion year mark, the Sun will be at its hottest point. The Sun does not have enough mass to explode as a supernova. Instead, when it runs out of hydrogen in the core in approximately 5 billion years, core hydrogen fusion will stop, and there will be nothing to prevent the core from contracting. The release of gravitational potential energy will cause the luminosity of the Sun to increase, ending the main sequence phase and leading the Sun to expand over the next billion years, first into a subgiant, and then into a red giant. The Sun has 8 known planets orbiting it. This includes 4 terrestrial planets: Mercury, Venus, Earth, and Mars, 2 gas giants Jupiter and Saturn, and 2 ice giants Uranus and Neptune. The solar system also has 9 bodies generally considered as dwarf planets and some more candidates, an asteroid belt, numerous comets, and a large number of icy bodies which lie beyond the orbit of Neptune. The Sun is moved by the gravitational pull of the planets. The center of the Sun moves around the solar system barycenter, within a range from 0.1 to 2.2 solar radii. The Sun's motion around the barycenter approximately repeats every 179 years, rotated by about 30 degrees due primarily to the synodic period of Jupiter and Saturn. Within 10 light-years of the Sun there are relatively few stars, the closest being the triple star system Alpha Centauri, which is about 4.4 light-years away and may be in the local bubble's G cloud. The Sun, taking along the whole solar system, orbits the galaxy's center of mass at an average speed of 230 kilometers per second, taking about 220 to 250 million Earth years to complete a revolution, a galactic year, having done so about 20 times since the Sun's formation. As the Sun goes around the galaxy, it also moves with respect to the average motion of the other stars around it. The period of the Sun's circulation around the point is about 166 million years, shorter than the time it takes for the point to go around the galaxy. Why did the Sun go to the therapist? It had solar plexus issues.